Okay, so let's talk now a bit about the pros and cons, or the advantage and disadvantage of a single agent versus a multi-agent system. You might remember this slide from previous video, right? And for this, let's now focus on the agent part. Okay, so we will do a lot of comparisons with agents and people, because I do believe that by analyzing how we work together has team of different persons, it also explains a lot how should we make AIs work together. And so let's first try to see here, why do people collaborate or work together? Okay, so why is the goal? So let's not consider the evolution part of it, like we had to work together to survive because of the nature, animals. Okay, so yes, that's true, but right now, why do we need to collaborate and work together? And most of the times we need it at least because of one of these reasons. So normally, when we are trying to do more complex tasks, we normally need a different set of skills. We need people that knows different things, and so we need them to work together to achieve a more complex task. Okay, but of course, you guys may say that one person can have different skills. So instead of having two people with two distinct skills, a project manager and a developer, we can have one person doing both project management and the development. But the problem with this is that we only get such an amount of capacity in our brains to be a multi-skilled person. Okay, we can know how to do, or we might know how to do a lot of things, but normally, if that is the case, we have the trade-off of not being really good in all of them. So it's something normally that we see in the skills of professionals, having like a T model, right? A T model where we have a certain skill where we are very good at it, but then we also have a set of different skills that we are okay-ish. We can manage them, okay? And normally, that's what happens with us. Of course, that we can be more transversal and less expert, or we can be more expert and normally less transversal. And that is not because of people's choice, of someone's choice. It's normally because of the limitation that we have in our brains, or in our memory, etc. But also, normally, we cannot have all those capacities and all those skills because we also lack resources. Lack of time, for example, lack of money, lack of tools to do it. Okay, it's very hard for me to become really expert in two different topics if both of the needs for me to become very good at those topics are higher than the time available that I have to know them. So, or for example, the money, if I need to take courses, if I need to buy tools, right, for me to be very expert in edge AI, I need to have money to buy equipment to use edge AI, like better local computers and smaller. So, and this happens a lot with other things. And because of this lack of resources, most of the times we cannot be alone as one person. We cannot be skilled with everything. So normally we also collaborate and work together because just one of us, it's not enough in terms of time. Also, another characteristic here of the time is that we are only limited to do one thing at a time. So if I'm a project manager and a developer, I cannot do the two things at the same time. I can, or I am developing, or I'm doing project management. If I stop one, I start the other, but I have to stop. And if we work as a team, we can parallelize work. We can have two people doing exactly at the same time the two different sets. And finally, I also believe that when we work together, we have this famous saying that the the total is higher than the sum of its parts or something like that. And I do believe in this situation, because most of the times when we are doing something alone, even if we have a lot of skills, we have our own bias in how we make those different skills work together. If I'm a project manager and a developer, probably I will give more attention to the project management tasks that affect more the development, and not, for example, budget or scope, things like that. And this is because we are biased on that. So there is no diversity in the way we thought about things, and the way we connect the different skills. But if we are using a team, a project manager, a developer, a tester, a business analyst, and so on, it is more likely than when we are working together, we are not just doing our tasks, but we are also discovering new things when we cross these tasks. And we can learn faster and achieve a better outcome than if simply each one of us four would do our task. So I also believe that this has an impact. And why is this important? Because most of the reasons that I talked here, they are also valid for AI agents. And most of the reasons why you want to implement a multi-agent system in terms of and not a single agent system can be because of one or more of these points here discussed. So let's now look into the agents. Okay, what can we do with them? Because here, indeed, there can be some differences when comparing to a person. So let's look, for example, at GPT 01 or 01, sorry, the reasoning model, or even 4.0. Okay, let's look into those big modules, right? Normally, these modules, they were trained with very, very, very big data sets of the internet, a lot of knowledge, and they have a lot of neurons, so to say, a lot of connections inside the module. So it means that the module is very big, and it was trained with, imagine, all the knowledge of the internet. Not exactly, but let's assume it. So this means that we have a very big module with a lot of parameters, billions of parameters, which we can more or less imagine this as being like a crowd of people. Okay, so I'm not saying that ChatGPT is better than one person, but in terms of his capacity, he can be compared to a group of people. Because if you guys know a person that has all the knowledge of the internet, I would like to know that person, but it doesn't happen. And with ChatGPT, that happens. Okay, yes, we can discuss other things that make us humans or not, but this is not what we are talking. We are just comparing the capacity of the module. And when we look into these type of modules, we might compare them to a crowd. Okay, so now imagine the exercise. Let's imagine that you want the help for this module to design you a logo, or you want the help of this module to make a study about artificial intelligence, for example. Now imagine that you need the help of these two tasks, and what you do in the world, instead of asking the help of someone or two or three people, you go to a crowd of 100 people and you say to at the same time to all those people and say, hey guys, I need to make a logo and I need your help. I want the logo to be this, that, with these colors, with this style. Or guys, I need to no, write a small article about artificial intelligence, and it has to have this, or that. And imagine that you guys ask this to 1,000 people, right? What will happen is that, of course, that this is not directly comparable with AI, but we can make here similar considerations. What will happen is that most of the people will sit and wait for tomorrow, and the people that have that skill or are affected by that need, they will act upon. But you still got a lot of people sitting, waiting, just existing, just consuming. So this can be helpful if you indeed have very complex task that requires a lot of skills, a lot of steps, very complex, and you need real reasoning. That's why we have the 01. It's called the reasoning module. Sometimes it's handy to have this. For example, for the deep research, if you guys already tried the deep research on ChatGPT, this can be handy. But this consumes a lot of energy to execute, because it's a very big, it has a lot of parameters and all of them are used. So even if they have lower impact, lower weight on it, they are used. So sometimes if we just want a logo or a small article, maybe we don't need to have such a big module with such a big crowd with all the knowledge of the world. And sorry, just going here back a bit, this is what normally, and probably you guys already heard about it, this is what normally it's called as a general AI. General AI, it's an AI that was trained to have general knowledge about everything. Okay, and normally they are big in terms of size. They need more energy to be more performant, because if they use the same capacity of the smaller modules, they would take more time. So they normally use more computational power to perform the tasks. But this is what is called the general AI. Now, again, if we want to do a logo or if we want to do a smaller task, why don't we simply consider having smaller modules? Okay, and when we say smaller modules, we might be talking about modules that are small but still they are powerful. They can have some general capacity, or we can even be talking about very small modules with just thousands or small millions of parameters, very target for a specific task. Okay, and this is on opposite of the general AI. This is what is called the narrow AI. Okay, so normally narrow AI are smaller modules, more economic, that are trained to perform specific tasks. So they do perform better those tasks that they were trained for. They are not so good for general purpose. So these are normally the two differences in terms of purpose of agents. So we are talking about narrow AI versus general AI. And please be careful that narrow AI and general AI are not the same thing of weak AI versus strong AI. You might have heard the two of them, or the four terms here, but they do not represent the same thing. Because the narrow AI and the general AI, we are talking more in terms of the capacity of a module to deliver the value, if it's narrow to specific tasks, or if it is general for a general purpose. Weak AI and strong AI, we are more talking about how close it can be related to being, a live being. So normally strong AI, it's very connected with consciousness, self-awareness, being alive, so to say. So normally strong AI, it's a module that it's not static in the way that we ask him something, he wakes up, performs the task, and then goes to sleep. So normally strong AI, it's more related to how close it is to a live being, to being alive. And weak AI, it's what we have basically nowadays in all the products we use normally. ChatGPT, smaller modules and bigger modules, they normally are all weak AI. Okay, so they are different things, we should not confuse them. Nevertheless, I'm going to put here a resource because I've found a video on YouTube that explains it's the philosophy of AI, and yeah, it explains these different terms to get to know better. So yeah, we have this. Okay, we have narrow AIs and we have general AIs. And why did I brought this up? Because normally, or the more we advance to the future and to precision, normally we are associating single agent complex tasks with general AI agents. Okay, so imagine that we have a complex task for both situations. Okay, so we are not talking about very simple tasks, we are talking with some complex tasks. If we have a single agent, this single agent needs to be a more general AI. If we have a multi-agent system, normally we can have more narrow AIs, agents working together, because again we are breaking down a complex system into smaller simple tasks, and because of that we can train each or configure each agent to be good at that specific task. Okay, so normally this is why we tend to evaluate single agents versus multi-agents. But this has here a complexity, because if you look into general AI and single agent and narrow AIs with multi-agent systems, it becomes harder to compare, because if it would be it would have been simple if you would compare single agents and multi-agent systems if all the agents were general AI. And in this way you would say, yeah, multi-agent system consumes more, because we are basically using crowds again to do a lot of tasks versus only doing only having one crowd. But at the same time, if we are comparing multi-agent system with narrow AIs with a single agent narrow AI, of course the single agent would be more economic because it's just one, but he would lack a lot of context variability. He would not be able to adapt to the tasks. So in this comparison here, what I can say is that normally we verify that the narrow AIs, they are better for precision tasks, for the tasks that they were trained for. So if you do like or do have a task that it's complex, and when you break that complexity, you start noticing that it has smaller tasks, that each one of them, it's very easy to explain and very easy to be specific for that, then you would gain a lot of potential by using smaller narrow AIs. Because the general AI, if you would use one general AI, he would be able to do probably the tasks, but he would be too general. I don't know if you notice this, not so much nowadays, or it becomes better, but in the old days of ChatGPT, the answers were very general, very generic. You seem that there was like no juice from it. Okay, so it's the reason of having a general mapping agent. So if you need really efficiency in precision tasks, there might be better to use a multi-agent system with more narrow agents, more target. Okay, Another thing is the capacity waste. I do believe right now that because we do put our work in a lot of modules spread along big cloud providers, OpenAI, Microsoft, Google, Amazon, Anthropic. So all those companies, they have huge servers with these modules deployed there, and we can use it. We are not noticing this so much, but I do believe in the future, when we start really growing the market of agents and we start having agents spread across smaller servers, or even in our own devices, in our own computers and mobile devices and so on, the capacity of the models will be very important, because we will not want to have a 21 gigabyte model in our phone. It's not easy to manage. It's possible, but it's not easy to manage. So the capacity will be more and more important. So if we have a complex task that it's performed by smaller narrow agents, you will have a less capacity waste. And the reason for that is, if you use a general AI, that general AI is the same in every task. So if you ask him for a logo, or if you ask him to write a research paper, the module, the parameters will be used, all of them the same. So you will use gigabytes and billions of parameters to do those two tasks independently, if they are simple or complex. But with narrow AIs, because they work together, if a multi-agent system is well designed, you might not even use half of the agents. You can have, for example, a system where it has 10 narrow agents inside of them in a very different patterns. It doesn't matter. But for a specific task, as designing a tool, maybe he just calls 2 agents. One distributes to another, delivers, that's it, and the others were dormant. So because of that, a multi-agent system for complex tasks that can be, again, break down into smaller specific tasks, normally it will tend to have a less capacity waste, assuming that we use these agents with smaller modules and trained modules. Of course, if we have agents here, narrow agents connected to a ChatGPT-4, we don't have a lesser capacity waste, because the module is a general module behind it. Okay, so this is one characteristic. Another one is the usage of resources, and this is a lot connected to waste. So again, these general modules, they tend to be big, very big, and when they are big, they escalate on the energy consumption, because they do need more operations to perform the tasks, to perform the routines. And of course, you guys do not notice this, because when you go to ChatGPT, it works below a farm of servers, very performant, with a very good capacity, so you do not notice the amount of energy that is consumed there. But they do consume a lot of energy. And again, the more we go to the future and the more we start escalating the agents, and start having more, there will be the need to manage the energy consumption of the models. And that could also be a reason for you to consider going between a general AI single agent or a multi-agent system. And finally, the easiness to follow up and control. Let's imagine this. Imagine that you have one employee that he is really good doing a complete project on his head. So you ask him, and he can project manager, he can develop, test, write things, and he works a lot. Let's even consider that he works 16 hours a day. So let's not impose here a resource limitation. So let's assume that this person, on his head, he can do everything. So he can work a lot in his head and do at the same time that he's developing, he's thinking how to test and how to manage the budget and the resources, etc., etc., etc. If you want to follow up his work, it is way harder for you to know what he is doing, what each of his skills did what. So what did this person project management did, what this person developer did. So it's much harder for you to follow up his head because it's one person with everything inside it. Unless he is also very good writing, logging everything that he does and he puts in a way for us to understand, it's hard to know what he is doing. But if you have a team and you are close to this team, it's easier. I'm not saying that it solves the problems, because you always need to be a good manager here, but it's easier when working with a team. It's easier to know the different steps that were taken. It's easier for you to check the outcome of the project manager, that he did the weekly status report and here it is. It's easy for you to check the developer and see that he developed this, or he has this ready, or the tester that he is doing tests. So with a team, it's more easy to follow the what they are doing. And you have the example on the previous application that I showed you guys, the orchestration pattern using workflows, right? The fact that we have OutSystems doing the flow of the instances, we can follow up better what happened, right? So it becomes more easy to follow up and to control the different steps. So this is basically the considerations you guys need to have when thinking of a single agent system or multi-agent systems, because normally if you want to solve complex tasks and you are considering the two of them, normally it will mean that you are considering between a general AI agent and a team of narrow AI agents. And it's important to look at these considerations, because if we are developing projects that we want them to be here in the next 5 years, in the next 10 years, we should also look into the scalability of AI that we are going to have. We also, let me just show you here one interesting thing, and give me just a second, I'll be right back. So this is a ebook that I found on LinkedIn. This company, We Aviate, they develop here several products, and they have a lot of products related with AI. I did not explore the company, but they have built this agentic architecture ebook. I'm going to put the link of this in the comments, but if you guys want to have a look into what makes an agent, then what are the different components of an agent, what is a single versus a multi-agent architecture, right? And we have here the strengths and weaknesses. We'll not go again here because it was a bit what we talked, despite the fact that they do have there is here some different opinions of what I discussed, but I think it's very cool if you guys would also read this, because you can learn a lot of. And we also have here the different patterns that they propose, and you might see here, for example, they don't have the orchestrator, but have the hierarchical. It's the same that we developed in the previous video, and they have here the network. That on my case, I'm considering this a variant of a collaboration pattern, so we will talk about this on the next chapter. And yeah, you go ahead, I will put this. Also a very interesting topic that I will not explore, but I will leave it here in the resources for you to see, is this article of Microsoft. How should we start doing user experience design for agents? And they also talk here what is an agent, about what is an agent. For example, I do like a lot this definition of the agent. It was one of the first definitions that I read, that instead of looking just into the what should it should have memory, it should use tools. Yes, almost all definitions that I hear about agents, they talk about this, but they also focus here into what is the purpose of the agent. And I think it's a very good definition, because he is the purpose is to work with or for humans, and agents may have chat experiences, but generally they go beyond typical chatbots. So we are always looking into AI in terms of chatbots, and agents go way beyond chatbots. We are not talking about chatbots, and I do like this definition. So I will leave this also for you guys to check if you want.